Good morning, students. Today our topic is classification of amplifiers. How can we classify the amplifiers? The transistor amplifiers may be classified as to their uses, frequency capabilities, coupling methods, and mode of operations. These are the uh, categories. On the basis of these we can classify the amplifiers. Now first is according to use. The classification of amplifiers as to uses are basically voltage amplifiers and power amplifiers, and the former primarily increase the voltage level of the signal, whereas the latter mainly increases the power level of the signal. This is the according to use we can classify the amplifiers according to use. Now second is according to frequency capabilities. Now according to frequency capabilities, amplifiers are classified as audio amplifiers and radio frequency amplifiers, etc. And the former, that means audio amplifier, are used to amplify the signal lying in the audio range. Audio range, that means 20 hertz to 20 kilohertz. And whereas the latter, that means radio frequency amplifiers, are used to amplify signals having very high frequencies. Frequencies must be very high. And third is according to coupling method. The output from a single stage amplifier is usually insufficient. The output from a single stage amplifier is usually insufficient to meet the practical requirements, and so additional amplification is often necessary. For this, output of one stage is coupled to the next stage. Output of one stage is coupled to the next stage depending upon the coupling device. This depending upon the coupling device used. The amplifiers are classified as RC coupled amplifiers and transformer coupled amplifiers, etc. So this is according to the coupling method. Now last is according to mode of operation. The amplifiers are frequently classified according to their mode of operation as class A, class B and class C amplifiers, and this classification depends on the portion of the input signal cycle during which collector current is expected to flow. This classification depends on the portion of the input signal cycle during which collector current is expected to flow. Now first is class A amplifier, and the class A amplifier is one in which collector current flows for the entire AC signal. If collector current flows for the entire AC signal, then this type of amplifier will be class A amplifier. Second, class B amplifier is one in which collector current flows for half cycle of input AC signal. If the collector current flows for half cycle of input AC signal, then this type of amplifier is called class B amplifier. Now third is class C amplifier, and this is one in which collector current flows for less than half cycle of AC signal. So if the collector current flows for less than half cycle of AC signal, then this type of amplifier is called class C amplifier. So this is the classification of amplifiers. Now feedback. What is meaning of feedback? Feedback can be defined as the process of injecting a fraction of output energy of some device back to the input is known as feedback. The process of injecting a fraction of output energy of some device back to the input is known as feedback. And types of feedback. Next is types of feedback. There are two basic types of feedback in amplifiers, and first is positive feedback, second is negative feedback. What is positive feedback? First is positive feedback, when the feedback energy, voltage or current, is in phase with the input signal and thus aids it is called positive feedback. And this is the diagram for positive feedback, and in this it is clear that the Vf is in phase with the Vin. Vf in phase with the Vin. Input signal and feedback signal both are in phase. Now next is negative feedback. When the feedback energy, voltage or current, is out of phase with the input signal and thus oppose it is called negative feedback. When the feedback energy, voltage or current is out of phase with the input signal and thus opposes it is called negative feedback. And this is the diagram for negative feedback, and it is clear in the diagram that Vf is out of 180 degree phase with Vin. Vf is 180 degree out of phase with Vin. In this diagram it is clear that the feedback network introduces 0 degree phase shift. Feedback network introduce 0 degree phase shift.